Okay, so yeah, good evening. Now we start this important theorem, which is called Binomial Theorem. Can you see still what I'm writing? Can you see this?
Yes.
Yes, everything clear?
Yep.
Okay, good. So what we do is I wanted to motivate you why this is the formula we need. If you remember, we had this. Of course, this is so trivial, nobody cares about that. A plus b to the 1 is just simply a plus b. But the first thing that you learned probably of this type when you were doing Math 1C is what happens if I write it to power 2. Then of course you know that this is a squared plus 2ab plus b squared. And usually you get this formula in the formula sheet, even though probably you don't use it that much or probably at all. This is another formula that I have a to the 3, 3a squared b plus 3ab squared plus b cubed. And the question is that can I find the formula for these so that I can find a plus b to power 4, a plus b to power 5, and in general a plus b to any natural power n. Is there any formula for that so that I can use the formula to expand that immediately? The answer to this question is yes, and the formula is what is in front of your eyes right now. It seems a little bit complicated, but this is not complicated at all when I explain that. Okay, is the idea clear? What is the motivation behind that? So we want to know a formula so that we can expand a binomial. Why we call it a binomial? Any expression that consists of two terms is called a binomial. So here we have two terms added. We want to raise it to some power, so that's called binomial theorem. And probably Newton was the first person who actually talked about that, even though this formula is not that complicated, but that's called Newton's binomial theorem. Okay, so today we want to talk about this formula. One way of proving this formula, because now you see the entire formula in front of your eyes, is using mathematical induction. Of course, this is doable, and I recommend you, if you're interested in solving hard problems, you can just use mathematical induction to prove this. But here, I don't want to prove it using mathematical induction. I want to prove this using a combinatorial argument. So I think just instead of tackling the most general problem that right now you see, let us concentrate on this particular case. The ideas behind that is exactly the same. So for example, if I ask you a plus b, let us concentrate on a plus b to power, for example, 3. This means that I have a plus b, and a plus b. Let us discover the properties of these terms after I am patient and multiply these three together. Okay? So what type of expressions or what type of terms you expect to get on the right hand side? Yes? What type of expressions you might expect? You might expect to have, so for example, let me concentrate on one single term. Yes? What is the generic form of this single term? Hopefully you agree with me that there is an a involved in that term. There is also probably a b involved in that term. And you also might agree with me that there is a number coefficient involved in that term. Is that understandable? So if I start multiplying these three terms, because for example I multiply a by a and then again by a, I will get a to the power of 3. You might say that, okay, this is only a. But you can imagine this is a to the power of 3, b to the power of 0, yes? So hopefully you agree with me. If I start multiplying these things, all the terms that I will get on the right hand side is of this type that you can see. Okay? But with some powers for a and some power for b. For example, there is a power, I would call it, I don't know, let me call it s, and let me call this one t. But what is the relation between s and t? What is the minimum value for s? Can you tell me? if you consider all possible terms, what is the lowest possible value for S that you might face when you see the expansion?
0.
Yes, so S is somewhere between 0, but there is a maximum, there is an upper bound for S. What is that in this case?
3.
It is 3, yes. And the same scenario is for T, but there is one more constraint on them. So of course S and T should be natural numbers. So let me write integers, because 0, sometimes we don't consider it a natural number. So integers, but there is another constraint. Can you see that? What is the relation between S and T?
Their sum should be 3.
Yeah, exactly. The sum of these two should be 3. So S plus T should be equal to 3. So these are the constraints that I have here. Let us concentrate on one of them. For example, let me choose S to be equal to 2. Let me choose T equal to 1. Of course, when I choose S equal to 2, I have to choose T equal to 1. There is no other possibility. So it means that let us concentrate on this term, a to the power of 2 instead of a to power S, and b to power 1. Okay, if in this multiplication this term happens once, then you agree with me the coefficient would be 1. If this term in this product happens twice only, then the coefficient would be 2. I don't know, if it happens 3 times, the coefficient would be 3. Do you agree with me? Is that understandable? Because if it happens 3 times in this calculation, if you face this term when you are expanding, if this term appears 3 times, of course you don't write them 3 times at the end, yes? But what you do, you will add them and write them as 3a squared b1. This is why I am telling you, if this combination appears 3 times, I don't know how many times it appears yet, I am just guessing. Assume that this term appears 3 times. Then what happens? It means that at the end, after expanding them, you will start collecting the similar terms. If this is happening 3 times, what happens? I will add them and I would write the coefficient 3. Is that understandable? What I am telling you is this coefficient that I am interested in is the number of times each particular combination appears. Is that understandable for everyone?
Yes.
Okay, now tell me, using your combinatorial knowledge that you have gathered so far, can you tell me how many, without, of course, this is simple, but I want you to understand, how many times do you think this combination will appear if I just start directly multiplying these things term by term? And how should I count this in general?
Should it be 3 chooses 1?
Can you explain a little bit? How did you come up with this number?
I'm just looking at the formula.
Okay. No, but I mean, we want to come to that formula. It's not hard, yes? When do you think that you face such a term? Because you know that when you are multiplying these things, you might choose A, you might choose A from the second pair, you might choose A from the third pair. This gives rise to A to the 3, which is not your term. Assume that you want to reach to A to the 2 times B. What does it mean? It means that one possibility is that I choose A from here in multiplication, I choose A from here, but I choose B from the last one. Do you agree? If I multiply these 3, this is one scenario that gives rise to A squared B. But is this the only scenario? So let me write everything in detail. So one possibility is to choose A here, B here. This will definitely give rise to this combination after the product. It might happen that I choose A here, B here, A here. But this will still give me this combination after product. Finally, I might have this B. I choose B from the first pair. I choose A from here and A from here, and then I get this one. Do you think that there is another possibility if I am interested to get this term? Do you see any other possibilities that gives rise to this combination?
No.
Hopefully this is acceptable for everyone. So it means that how many times this will be this will appear in my expansion? 3 times. Yes, just 3 times. So you see, now you realize that the coefficient of this definitely is 3a squared b. And then if I write the formula in front of you, you definitely see that this is correct. This becomes a to the 3 plus 3a squared b plus 3ab squared. This is the correct formula, b to the 3. Yes? So you see that now the coefficient that appears next to a squared b is exactly 3. The reason is that I have only 3 ways of generating a squared b1. Because for generating a squared b1, I need 2 a's, I need 1 b. Okay? And then I have 3 options available. Either I choose a from here, b from here, or a from here, b from here, a from here, or b from here, a from here, a from here. Nothing more. So definitely a squared b1 will appear 3 times in this expansion, depending on my choices of the terms of each one of these binomials. Okay, just tell me, is that understandable more or less?
Yes.
Okay, now, for example, can you predict, if I ask you by looking at the formula, what is the coefficient of a to the 3, you immediately realize this is 1. Okay, but let us predict this before expansion. If I want to generate a to the power of 3, how many choices do I have? I want to generate a to the power of 3. So what should I choose from the first pair? My goal is to generate a to the 3. Definitely I have to choose 1a from here. For the second one, again I have to choose 1a. I am not allowed to choose b because I need 3 a's. So it means that how many possibilities are there for choosing 3 a's? Each one from one binomial, one possibility. This is why you see this is 1. Yes? Is that understandable?
Yes.
Okay, now let us try to understand this, even though the formula is not fully written here. So let me write something in front of you. A plus b to power 7. Okay, so if I want to write this, I already know what are the terms. The only problem are the coefficient. The only problem is finding the correct coefficient for the term. So because I know that all these terms should be of this form, but this time s plus t should be 7. Okay, so how many possibilities are there? I might get a to the power of 7, or I might get a to power 6b, or I might get a to power 5b2, a to power, I don't know, 4b3, a to power 3b4, a to power 2b2, b5, and I don't know, a, b6, and finally b7. These are the only possibilities that I will face after this expansion. If you don't understand something, please interrupt me immediately, okay? The only problem is that the coefficients I need to know. And then, hopefully, you understand what is the meaning of the coefficient. The coefficient of each term means the number of repetitions of each one of these terms. If I write this 7 times and multiply it, yes? If I write this 7 times and multiply it, it will give rise only to these combinations. These are the only possible combinations that I will face. The only problem for me is to answer these question marks. Okay, so let us try to think about this a little bit. Okay, can you tell me what is definitely this coefficient, the first coefficient, what that should be?
1.
1. Why? Can you just elaborate why according to this argument?
There is only one option to gain a power 7.
7, and that is to choose a from all of these. So it means that I am writing this 7 number of times next to each other, and I want to get a to power 7. There is only one way that I can come up with I can end up with this a to power 7, and that is to choose a from here, choose a from here, choose a from here. Okay, so this is simple. So let me write with a different color. Definitely this is equal to 1. Okay, can you tell me what is the coefficient of the next one? How many times do you expect that this term will appear if I start multiplying all of them? So remember that you need to have 6 A's, and of course the next one should be a B. There is no other options available. So how many times do you think that this term will appear?
7 times.
No.
Well,
Yeah, 7 times. Thank you. You're right. So what is your argument?
there are 7 different ways in which I can pick 6 A's and 1 B.
Yes, so it means that you just concentrate on 6 A's, because automatically what is left for you, you have to choose B from that leftover pair of brackets, yes? So for example, one possibility is that I choose the first 6, from the first 6 pairs, I choose A, so then I will have 6 A's coming. And then I have to choose B from the last one. This is only one possibility. But I don't have to choose B on the last one. I can choose B on the 6th one. Yes, I can choose B on the 5th one. So immediately you realize there are 7 possibilities. So definitely the next answer would be 7. Okay, so these are easy to guess. Okay, so can you tell me immediately what is the last coefficient here? And what is this one? Yes, that one was. The last one is?
7 and 1.
Yes, 7 and 1. Hopefully this is understandable for all of you. Yes, there is no difference between A and B in principle when it comes to repetition in this problem. Okay, but let us try to understand the next one, because if you understand the next one, definitely you understand the whole theorem. That's enough. So can you tell me what would be the coefficient that I want to put here? So how do you think about the problem? So you need to think about in how many ways I can choose 5 A's from these binomials. Of course, the leftover, the two left ones, I have to choose B from them. So you don't need to think about A and B, because when you choose your A's, the leftover pairs, I have to choose B from them. Okay, so in how many ways I can choose 5 A's?
Seven choose 5.
7 choose 5, yes, because I want to choose how many things I have here. I have 7 of them, and this problem is a combination problem because the order, it doesn't matter, yes, because A plus B times A plus B is the same. If I interchange these two, nothing will happen. So if I ask you in how many ways you can calculate that, you would say that, okay, I will do it in this many ways. 7, 5. Is that okay for everyone? So what the number is here is just 7, 5. But do you remember there is another way to write 7? So let me write this one. In principle, this one here can be written in a different way. I can write it 0 and 7. Do you remember? If I ask you what is 0, 7, you would say this is exactly equal to 1. What can I write for 7 in this way? I can say that I can write it as 7, 6. Yes? So this is another way of writing 7, 6. Okay? Then the answer to this one is 7, 5. The answer to the next one is 7, 4. But of course, the order that I have written here is more natural because I start from 0 up to 1 up to 2, etc. So what we can do here, you can also see this 1 can also be written as 7 over 7. But do you remember we had a formula n minus r is equal to n and r. These two are the same all the time. Okay? So if I ask you what is the answer to this one, instead of writing 7 from 7, concentrating on A's, you can concentrate on B's, yes? Here I have chosen 7 A's, it means that I haven't chosen any B's. So there shouldn't be any difference between them. Your previous knowledge confirms that these are the same thing. So if I ask you what is this coefficient is coming from, you can write that this is 0 from 7, and what is this coefficient is 7, 1. What is this coefficient? Instead of writing 7, 5, you can 7 choose 2, and you can continue. So that is the idea behind finding these coefficients. Okay, so now is there any question here? Is that understandable?
Yes.
Okay, so let me clean this mess. We don't need it that much. So in principle, if I want to answer this question, so a plus b to power n is some expansion. We have a coefficient here, and then we have a to power s and t. So let me write it again, the same thing. So this becomes s, b to power t, and then what we know is that s is somewhere between 0 and n, t is somewhere between 0 and n, s and t are integers, and more importantly, s plus t is equal to n. Okay? So if I want to rewrite it in a slightly different way, I would say that this can be expansion. So here I want to answer this question mark yet, but instead of a to power s, I can write a to power n minus k and b to power k. Yes, it doesn't matter, because now you see that the sum of these two is still equal to n. So it doesn't matter if you write two variables and later emphasize that the sum is n, or intentionally write them in this way so that you can immediately see that the sum of these two is always equal to n. But then the point is that what the coefficient is, let us concentrate on the way that I can construct b to power k. For constructing b to power k, I need to choose k parentheses from this and choose b from them, yes? Because a plus b to power n means a plus b times a plus b times up to a plus b n number of times, yes? In factors. But I want to have b to power k. So it means that when it comes to choosing between a and b, I have to choose b k times. I have n factors, but I have to choose b k times. In how many ways I can choose b k times? I would say n choose k. So this would be the coefficient that is missing here. Okay? So it means that I have to calculate all these possibilities with these coefficients and start adding them. Or more compactly, using the sigma notation, we can write it in this way. Hopefully it's understandable for you what is the idea behind that, behind this proof. This is a very interesting proof. You don't even need to know the right hand side. In principle, you are able to construct the right hand side yourself. So I would say it's more powerful and more elegant than proving this by induction. Proving this by induction is because you train yourself improving your skills in mathematical induction. But this method is more powerful than the method of mathematical induction because it will generate that. So let us remember this. This formula, of course, will be given to you in the formula sheets, but next year you have to memorize that. Of course, if you understand that, there is no big deal to memorize that. This combination you need to know. Okay, so let us do immediately the first example. Use binomials theorem to expand each of the following items. Of course, you immediately know the formula of the answer to the first part, but let us pretend that we don't know and we want to find it using the binomial theorem. Yes, so what should I do? Let me make it a little bit smaller so that you can see that. So a plus b to power 2 is equal to, the combination is this is 0, 1, 2 up to n. What is this n? This n is the number that you see on top. Here n is 2. Okay, and then a starts with power of n. Each step you deduct 1 unit from the power of n, power of a, and add 1 unit to power of b. Here b was to power 0, the next one is 1, the next one is 2, and coming until you reach to b to the n without any a's. So if I want to continue this, in principle I should write 0 from 2, choose 2, 0, a to power 2. The next one I should write choose 2, choose 1, a to power 1, b to power 1. Okay, so in principle this is b to power 0 if I want to emphasize. And the next one is 2, choose 2, a to power 0, b to power 2. This is the way that you need to think about this problem. But of course, if you remember, if I ask you what is this, by convention this is 1, and then I will have a2, b0 is 1. And if I ask you what is this one, this is also easy to calculate. I have 2 people, I want to choose one of them. In how many ways I can do, you can choose 2. If you don't like this method, you can write the formula. Yes, 2 minus 1 factorial. If you calculate this, this is also 2. And the other one is 1 again, b2. And this gives you exactly the formula that you know. Yes. So let me skip number 2. You can do number 2 yourself. Let us do number 3 here. So a plus b to power 4. So how should I write it? I start from choose 4, choose 0, a to power 4. The next one is 4 choose 1, a to power 3, but b. The next one is 4 choose 2, a to power 2, b2. The next one is 4 choose 3, a to power 1, b to power 3. And finally, 4 choose 4, b to power 4. So this is the way that we can expand this, a very nice expansion. And now you can open this. Hopefully you know the answer to the first part. This is the convention, so it is 1. I just simply write a to the 4. The next one, what is the next one? I have 4 people. You always interchange between analytic calculation and combinatorial arguments if possible. So here I would prefer to write it immediately 4, because I have 4 people. I want to choose one person. It means that I have 4 options available. But for this one, do you remember I told you a trick to calculate it more effectively? I would write 4 times 3, and then in the denominator I just simply put 2 factorial. If you don't like this, you can just use the normal method. And the answer to this is 6. So what I do is 6. And then from here onward, from the middle term onward, I really don't need to calculate anything at all. We don't need to calculate 4 choose 3, because 4 choose 3 by the theorem that I mentioned earlier, this is exactly equal to 4 choose 1. If it was 4, this is also 4. So the answer to this is 4ab3, and then the next one is 1 again, b4. So you see that the coefficients that are equidistant, the equidistance from both sides are the same. So here you see this one and that one are the same. This one and this one are the same. Of course, this is single, so there is nothing to compare with. So that is 6a squared b squared. So that's important to know. And if I ask you a question, how many terms do you think are involved in this expansion? No, be careful. That's usually people make mistakes. This is why I want to mention it.
N-1 terms?
Yes, n+1 terms. Because from 1, 2, 3 up to n, from here to here there are n terms, but I have one single extra term in the beginning. So there are n+1 terms, not n terms. Okay? And if I ask you what is this, which term is this, you would say this is the first term. This is another matter of confusion. Please be careful about this. If I ask you which term is this, this is not the first term. This is the second term. This is the third term. So don't fall into this trap that this number gives you the term number. No. You see, here this number is 0, but this is apparently, clearly, this is the first term. Here this number is 1, but this is not the first term. This is the second term. Okay? So this is different. So be careful about this point. I think I have written it for you. Yes? So here, note that the number of terms in the expansion is n+1. So be careful about this point. Moreover, if t sub k denotes the kth term in the expansion, t sub k is not this formula. You see, if I tell you what is this, this is not the kth term. This is the term number k+1. Okay, so if you want to say what is the term number k, it means that you have to replace k with k-1. Yes, so this becomes n minus k plus minus 1 b to power k-1. This is the kth term. What you see in front of the sigma is not the kth term, is the k plus first term. If I ask you what is the kth term, that is the same formula, but k has to be replaced with k-1. And here, if I do that, it becomes n minus k plus 1. And that is exactly what I have written for you in the remark on the next page. Okay? You don't need to memorize that. This is not, of course, given in the formula sheet. This is something that you need to understand yourself. And that's exactly what I have written there. And I want to give you a much simpler way to expand these things using by hand. You don't need a calculator or whatever. In one of the previous examples last week, I asked you to show this formula. We showed that, and actually in that we finalized this. We've solved this problem. Now, if I ask you what is the relation between this one and how can I use this in this new context, this will give rise to this formula, even though it's a very, very long formula apparently. I have written it in words, but it is extremely useful and simple if you have it in mind and use it immediately. So this tells you that is exactly this formula. I am interpreting it in words in this new context. So the coefficient of the kth term in this expansion is equal to the exponent of a in the previous term multiplied by the coefficient of the previous term divided by the term number -1. Okay, you might think this is very complicated, but it is much, much simpler than it sounds. So let me just, but if someone asks you why this formula is correct, you need to say that, okay, this is exactly this formula. Okay, so let me try to show you how you can use it immediately. So if I want to expand this using the above remark, of course, this is not a have to, but if you want to do it quickly, which if you care about doing things quickly, I would prefer to write it in this way. If I want to expand that, what I write? Everyone knows about the first term. So what is the first term? The first term is definitely a to power 7. The next term is definitely a to power 6b. The next term, of course, with some coefficients. I will come back to coefficients. But everyone knows these combinations. That's very easy to do. So this is something you don't need to do anything with calculator or formula. You just know all the combinations. And of course, you know the first coefficient. The first coefficient, so let me put some here. We want to add them, but I need to find the proper coefficients, yes? Of course, you have the formula, but in that way, it takes a long time to calculate, but in this way, it is simple. What I am telling you, if you want to calculate this coefficient, do this. Go to the previous term, take the exponent of a, multiply it by the coefficient, and how many terms you have written before that? One term. So I would say 7 times 1 divided by 1. The answer is 7. So what I write here is 7. Just be patient, I will repeat it again. So for example, I want to calculate this number. I go to the previous term. I go here, multiply this by that, 6 times 7. How many terms I have written so far? 2 terms. I divide that. It becomes 21. So definitely the answer here is 21. Again, let me do another one. So what I do here, I go here, I want to find this number. I go to the previous term. I take this one 5, multiply it by this coefficient, and then divide it. How many terms I have written before that? 1, 2, 3. So I divide by 3. And this is 7, so it is 35. You see, it's very fast and effective. Of course, you can use the formula above. That is actually coming from the formula above, but this is a very efficient way to do that. Okay, and then of course you really if you can continue in this way, but you don't need to, because you know that the coefficients having the same distance from the ends are the same. Okay, so for example, if I ask you what is this one, this is 1, 2, 3, 4. So this is 1, 2, 3, 4. So the coefficient of this and the coefficient of this should be the same. So you really don't need to calculate anything. So that is 35. But if you want to follow the same strategy, if you want to calculate this, you go to the previous term. You take this exponent, multiply it by that. And how many terms I have written so far? 1, 2, 3, 4. So I divide by 4. You see 4 and 4 are gone. What is left is 35. So you can calculate it in this way and that way. So that's 35. And if you don't mind, let me not spend some time on it. This becomes 21. The next one becomes 7. So I would prefer to do it so quickly like that. So hopefully you'll learn what is going on and you can immediately calculate this. Any questions here? If you don't like it, of course, you can just write down all the formulas in detail and calculate them. Okay, so now let us go to the next one. Here, so be careful about this one. So this is this. If I want to expand it to power 4, so you know what to do. Here, this number is playing the role of A, minus 3y is playing the role of B. Okay, so what does it mean? It means that definitely this will start with 2x to power 4. The next term would be 2x to power 3 multiplied by minus 3y. The next term would be 2x to power 2 minus 3y to power 2. Yes, and the next one, let me write it here. Yeah, we can write it here. 2x to power 1 minus 3y to power 3, sorry. And finally, let me write here, minus 3y to power 4. Okay, so let me put here. Okay, so you know that this number is definitely 1, so the last one is also 1. But if I ask you what is the number that I have to put here, if you learn this rule, that's okay. Otherwise, you can use the formula in the book. So I will take this one and multiply it by that. It becomes 4 times 1, and I divide. How many terms I have written so far? 1. So the answer here should be 4. So I put a 4 here. And if I want to calculate this, I go to the previous one, take this one and multiply it by this. How many terms I have written so far? 2. So the answer becomes 6. So that number is definitely 6. And I don't need to calculate the next one. The next one is definitely a 4. But you shouldn't leave it like this. You need to simplify that. So simplifying that means I have 2x to power 4 multiplied by 1. So the answer is definitely 16x to the 4. So how much is this number? 2 to power 3 is 8. 8 times this is 32. 32 times minus 3 is minus 96. So the answer would be minus 96, x to the 3 and y. The next one, 2 to the 2 is 4. 3 to the 2, minus 3 to the 2 is 9. Yes, and 9 and another 6. So if I multiply them, what is the answer? This is 36, and if I multiply it by 6, 216. So the answer would be plus 216, x to the 2, y to the 2. What is the next one? The next one, I have a 2 times that one is 8, but I have minus 3 to power 3. What is the answer? So minus 3 to power 3 is minus 27, and minus 27 times 8 is how much? Am I right? 4, yeah, that is 216 again. Yes, so minus 216. Yeah, please correct me if you think that I am making mistakes. And then the answer, the final answer is 81. Be careful. Here you see that the numbers are not the same, even though they have this. Oh, sorry. This is 81. This is 16. This number is minus 96. This number is minus 216. The rule that I told you about, that these coefficients should be the same, are only for the standard case, that these coefficients are 1. If I have an extra coefficient in one of my terms or in both of them, you see that I lose that symmetry. So the first term has coefficient 16, whereas the last term has coefficient 81. So that rule only works if I have this symmetry. It means that I start with the standard one. Any questions here? Okay, good. So this is the practical things that you need to know, but more interesting problems are of these type of problems, yes? We have a little bit of time, so yes, we can finalize this. So these type of questions you need to be very good in answering. So in the expansion of this, determine the coefficient of this term. Okay, first of all, tell me, do you really expect that this term is among one of the terms after expansion of this expression? And why? For example, do you expect...
Because the sum of 5 plus 13
is 18, yes, exactly. For example, if I ask you, if I give you this question, and I ask you what is the coefficient of this, what is your answer?
0.
0, yes, because this term will not appear in this expansion. Why? Because the sum of these exponents is equal to 19, and it cannot happen by this in this case. Yes, you are right. So in that case, you immediately say that the answer is 0. But what about this one? Let me give my own experience. If I want to solve this problem, I put the formula from formula sheet or from my head, or I don't know, in front of me. So this is the formula. K goes from 0 to n, and then I have k, n choose k, a to power n minus k, and b to power k. So this is the formula available for you. And then you see that a is being replaced by 3x in this problem, and b is being replaced by minus 2y. So what I do, I will rewrite, and then n is being replaced by 18 in this problem. So I'm patient and rewrite this once more. So I would write 3x minus 2y to power 18. Then you need to be careful. So for example, k goes from 0 to n. N is 18 in this case. N choose k, but n is 18. K is just simply k. And then instead of a, I put 3x to power n minus k, but n is 18, minus k. And b, which is minus 2y to power k. So what I have done, I have put the formula in front of me and I have done these substitutions. And then what I do, I simplify the expression inside. So what does it mean? It means that this becomes this. This is 18 choose k, but you see that I have a 3 to this power and I have a minus 2 to this power coming out. So this becomes 3 to power 18 minus k times minus 2 to power k. Then I will have x to power 18 minus k, y to power k. Of course, this is not obligatory to follow every step that I am telling you. That's up to you. But this is the way that it will work. Okay, so you see it seems a little bit complicated, but it is not. So if you expand this expression, this would be this sum. But now you are interested in a case that you have this term. Comparing this one with this one, it's very simple to see that k is equal to 13. Yes? Compare this term by that term to determine your k value, your suitable k value. So it means that by comparing this, you immediately realize that k is equal to 13. Okay, and then what is the question? Determine the coefficient of this term. Coefficient means the number part, the multiplicative constant multiplied by that term. But this is not just this one. Yes, the whole expression is that number that you are looking for, but you found k is equal to 13. So what you need to answer, the question mark is equal to, you need to read this coefficient and replace k with 13. So what happens? It becomes 18, 13, and then you have 3 to power 5 minus 2 to power 13. And I really don't care if you want to simplify it or not. You just write it in this form. Yeah, that's it. We don't need to simplify. Of course, if you have calculator or computer available, and if you really want to calculate the numerical value at the end, you have to calculate all this number. But that is the number that I was looking for in asking this question from you. Is that understandable? One thing that I want to mention is that don't think that this is always the coefficient. Yes, this is the coefficient if this is a and b. But if a and b has some coefficients themselves, you need to extract them out and consider them and combine them with the formula, the coefficient in the formula, and consider the whole package as the coefficient of the particular term that you want to solve. Okay, so let me try to solve the other problem here. In the expansion of this, which term, if any, is independent of a, and what is that term? Independent of a means that somehow, for some reason, a has been simplified. So if I want to write an example for you, so let me write something this to power 2, for example, then I will clean it. If I ask you using your Math 1C knowledge, expand this, it becomes the first one to the 2, 2 times the first one times the second one, and the second one to the 2. So you see that after simplification, what is left for me is x squared plus 2 plus 1x. And now I would say the middle term is independent of x. There is no x involved in the middle term. This is more or less the same question for a little bit complicated expansion. and then you see that something is up in the numerator, something in the denominator, might be the coefficients are adjusted in a way that some term becomes independent of a by cancelling a out from the numerator and the denominator. So we want to discover if this is the case in the first place, and if it is, what is that term? That's the meaning of this question. Okay, so how should I answer this question? Again, let me start from scratch again. So I will go to the formula sheet and put the formula sheet in front of me. The formula in front of me. So k goes from 0 to n choose k, a to power n minus k, b to power k. Okay, so what I do, here I need to do my replacement. So I will replace a with this term. I will replace b in the formula with this term. Okay? And then I replace n with 17. And I will patiently rewrite it again. Now, of course, you don't have to. So this goes, sigma goes from 0 to number to n is 17. Choose 17, choose k, and then I have the fourth root of a cubed to power 17 minus k, and then I have 1 over the third root of a squared to power k. This is what formula tells me, yes? Now I will start simplification as much as possible. And in this kind of problems, you need to remind yourself of these two formulas. So the nth root of, I don't know, for example, x is x to power 1 over n, and the nth root of x to power m is x to power m over n. So these are the formulas that are handy in these type of problems. Okay, so you need to do the same thing here. So what I do, let us concentrate on this bit. What I do, I will concentrate here. Okay, so the question mark becomes equal to, let us simplify this expression. So the first term becomes a to the power of 3 over 4, but there is another power on top of that. And the other one is 1 over a to the power of 2 over 3 to the power of k. But if you don't mind, let me bring this up and make it negative. And then you know that this is an exponent, this is another exponent, so these two exponents should be multiplied. So let us write it. A to power, if I multiply 3 inside, it becomes 51 minus 3k divided by 4, multiplied by a to the power of minus 2k over 3, yes? So I moved it up, it becomes minus 2/3, and then to power k, I multiplied them and I wrote it here. But you immediately realize that these two are the same, so it means that I write the 1a and I start adding the exponents. So it becomes 51 minus 3k over 4 minus 2k over 3. Yes, so this is simplified version of this question mark. But your goal is to make the term, if possible, independent of a. If you look at the whole package here, the only a dependence is coming from this question mark because there is no a dependence here. So if I want to make it a independent, it means that I need to get rid of a from this term, from this combination. And we simplified this, we realized there is only one way to make it independent of a. Can you tell me how?
When the exponent of a is 0.
Exactly. So it means that the exponent of a should be equal to 0. So for the term to be independent of a, we have to have 51 minus 3k over 4 minus 2k over 3 equals to 0. So then it means that I have to solve this equation and find the possible value for k. If there are no answers in this equation, it means that it is not possible to make it a independent at all. If there are some answers, those are independent terms, depending on how many values you can find for k, but it is clear that in this equation might be I will get only one. Yes, how should I do that? I move this to the right. So this implies that 51 minus 3k over 4 is equal to 2k over 3. So then it means that 4 times 2k is 8k's is equal to 3 times this number, 153 minus 9k. Yes, I move 9k to the left, it becomes 17k. Yes, and then it becomes 153. By the way, let me just divide 153 divided by 17. How much is that? It's 9 times, yes? So what happens if the answer becomes 9 over 2? What is your interpretation then?
There is no term.
Yes, there is no term, because what is k? K is the counter of the sigma. The counter of the sigma cannot be a partial number, cannot be a fraction, it should be an integer. And even if you solve this one, for example, what happens if you get 19? What is your interpretation then?
It doesn't exist because k has to be smaller than 17.
Exactly. So be careful about these points. But of course, in this problem that I have designed, actually all of them are correct. So 9 is an integer, it lies between 0 and 17, so it's acceptable. And there's only one answer to that, and it means that, okay, yes, this is the only term which is independent of a. And then what is wanted in the problem, which term, if any, can you tell me what is which term? What is the number of term which is independent?
10th.
10th term, thank you, yes. Don't say 9th term, because this is not the 9th term. K is 9, so the 10th term, yes, is independent of A. Okay, and how much is that? And what is that term? What should I do? It means that this part, I don't need to be worried. If I choose k to be 9 and put it here, this will vanish. So what I need to put is, I need to put k there. It is 17, choose 9. So this is the answer that you need to provide for this question. Okay, is that understandable? Okay, thank you. So I will continue some complementary notes on Monday. I don't know. We will start on graph theory on Thursday. So yes, but I will try probably give you more examples of this and the previous topic that I was covering. So to make sure that everything is compact and in one place you understand what's going on, and on Thursday at least I will start the introduction to graph theory. Okay, let me just pause this recording. Hopefully it worked.